Okay, so in question 7, they say that A, sketch the graphs of f of x 3 to the power of x plus 1 and g of x 3 to the power of 2x on the same set of x's shown. Show any asymptotes, intercepts with the axis, and points of intersection clearly. Right, and then we're gonna draw the function on this given grid, right? Now, looking at these kinds of given functions, the f of x and g of x, can you see that they are all exponential functions? Both of them, they are all exponential functions. So f of x and g of x are both exponential functions, are both exponential functions, ne? Exponential functions. And then when you look at them, if you look at both of them, can you see that it's only 3 to the power of something, or it's only 3 to the power of something there at the top and not plus q? There is no part where that function was either moved up or downwards. So those two functions, ne, f fx and g of x are both gonna have a horizontal asymptote. Horizontal asymptote of y equals to 0. Basically, they're gonna both have a horizontal asymptote of y equals to 0, because both, they don't have a point where they are being shifted or translated up or down. Right now, what we're gonna have to do now, we're gonna now try finding the intercepts as well as the points of intersection for both of those functions, right? Now let's quickly find the points of intersection, because it seems like it's much easier. Now, remember, for you to do the points of intersection is the points where two of those functions are equating each other. So it's when f of x equals to g of x, right? Now remember, f of x is given as 3x plus 1, 3 to the power of x plus 1. G of x is given as 3 to x. Now remember, they both have the same base, so we can drop them and say x plus 1 equals to 2x. And then we can take the x to the other side, then we should have x equal 1 equals to 2x minus 1. So basically our x is just gonna be 1, and then we can substitute that x equals to 1 in either one of those functions. Let's sub in into f, so we can say sub x equals to 1 into f of x. If we do that, we should get y f1 equals to 3, 1 plus 1. I think you should get 9. Yes, you should get 9. So the point of intersection, point of intersection is actually 1,9, right? Now the next step that we're gonna have to do is finding the intercepts for both the functions. Now let's try finding intercepts of f of x first, of f of x. Now to find the x-intercept, x-intercept, we're gonna say let y equals to 0, right? And then if we let y equals to 0, so we're gonna say 0 equals to 3x plus 1. If I look at that function, it can't have an x-intercept. No. When I look at both of those functions, they can't have an x-intercept. No, yeah, no, I don't even know what was I thinking there. They can't have x-intercepts because they have a horizontal, they have a horizontal asymptote which is y equals to 0. And so basically they're gonna start here and go there, start here and go there. So they can only have y-intercepts. Sorry about that. They can't, both of them, both f of x and g of x can't have they can't have an x-intercept. So I'm gonna say y-intercept, y-intercept for f of x. Then I'm gonna say let x equals to 0. Then I'm gonna say y equals to 3x plus 1. So my answer is basically gonna be 3 to the power of 1, which is actually 3. So that y-intercept is basically 0, 3. Now the y-intercept for g of x, I'm gonna also do the same thing. Let x equals to 0. Then I'm gonna say y equals to 3. 2 times 0. 2 times 0 is 0. If you say 3 to the power of 0, you should get 1. So that intercept should be 0, 1 for f of x. So we now have the asymptotes. We have the y-intercept for both of them. So we can now probably try drawing those functions. Now the f of x one, I'm gonna do it in green. So the y-intercept is 0, 3, 1, 2, 1, 2, 3. So it starts here. Ne? Then I'm gonna try using the calculator to find more other values. Let's try 3 to the power of negative 2 plus 1. It's a third. No. Let me try 3 to the power of negative 1 plus 1. I get 1. So if you go from negative 1, it's somewhere here. Somewhere here. Ne? And then I think if you go further, like maybe minus 3, maybe let's take 4. Yeah, I think for this one we can let's see 3 to the power of 1 plus 1, we get 9. When it's 1, we get 9. 9 is here. So let's try connecting the dots. So it goes on and on and on, and then we can put it that way, ne? Probably, and then yes. Then for the blue one, 0, 1, 0, 1, and also remember they have a point of 1, 9, ne? 1, 9, so it intersects there as well. So I can draw it from ne, and then going down and down and downwards and so forth, ne? So I can draw it that way. So the function of the blue, I draw it, then the green one is there. So when you do sorry, my sketch may be a little bit rough, but then when you do draw the functions, ne, this is how accurately they should be. This blue must cross there at 1, 9. Now they said that we gotta show every point, ne? Remember here it's 1, 9, and then remember that coordinate there, it's 0, 3, it's 3, 0, and the other one there is 0, 1, 0, 1. Right, and then if you do that, you should get your full marks in the paper. Okay,